For this lesson, it's the third part of our lesson on volume. We're going to look at what's called the slant height. So our objective is I can use the slant height to find volume. So to start us off though, I want us to start with an opening where we use nets to identify figures, just to review a little bit. So pause the video, identify these two using those nets, and then if it might even be helpful, you might even want to make a copy, cut them out, fold them, and try it yourself. So pause the video and try it out. Now that you've tried that, let's take a look at these. This first one, I have trouble with these sometimes, so what I did was I took it and I actually folded it up and made it into a little cone here. So as you take that and wrap it around this base, this is the base circle, and wrap it around, it becomes a cone. So this first one's a cone, and on this cone, this line here, when it has either a cone or a pyramid, that line there is what's called the slant height. So if we were to look at a cone, it's where we would follow from the point down to the edge of the circle is our slant height. Okay, so that's what our slant height looks like. This second one, so this one's a cone. This second one, if you were to fold it up, take it and fold it up, notice that the points would come together and it would go like this into a triangular prism, okay, as you fold it up. And so when we look at that, what's nice about these, when you look at a figure like this, is it's got two parallel triangles as your bases, and then these flat sides are not parallel, so they can't be the base. Those are the faces of your triangular prism. Okay, now what's nice about looking at these is you could almost take time to find out what the surface area is by finding the area of each of these figures in the net, and then before you fold it up, you'd have the surface area. So, but that's going to be a future lesson when we talk about surface area. Okay, but that's how you'd use nets to do that. Okay, now this next part here, where it talks about slant height, you actually had, I put a net there on the figure for the next one. Looks like this, and if you were to fold this one up, it also would come together, all the points together, and would form a pyramid like this. So we had a cone, this one's a pyramid, and that altitude of that triangular face, that's what's called the slant height, just like we had in the other one. So if you look at a figure like this, if we were to follow from the point down on the face down perpendicular to the edge, that would be our slant height for this pyramid. So this pyramid that we have here, the slant height is where you would draw it from the point down to the edge and make it perpendicular. Now sometimes it's hard to imagine what these are when you're doing it in 2 dimensions with the figure, but you got to be thinking. I start thinking in 3 dimensions. So that's going to be a big skill to work on with these, is when you see a 2-dimensional figure, be able to imagine the 3 dimensions and imagine that as the line coming down this face here that's from the point down to the edge. Okay? So now, that's the slant height. To do these types of problems, let's do the problem down at the bottom. The bottom problem has this side listed as 28. And then it's going to be a square base. It doesn't say that on there, so you might want to draw, put that there, that has a square base to it. It says that the slant height is 50, and we want to find what the volume of this is. The problem is we don't have the height of it. Okay, we can figure out if this is a square base, we can figure out what the area of the base is, because our volume formula, if you remember, is going to be 1/3 times the base times the height. That base, we've got that information. That's going to be just a 28 by 28. But this height we don't have yet. We need that information. So here's how you take and do that on a problem like this. What you have to do is, when the information isn't fully there, you've got to draw in some more information. I'm going to drop down the height right down the middle here, draw it down. So it's from the point directly to the middle of the base. So when you're looking at your pyramid, it's from the height down to the middle of the base, directly drop down. Okay, that, if I were to draw it over to the foot of our slant height, we now have a right triangle. So if I were to separate out that right triangle here, where this is the height of that pyramid, this is down here the length here at the bottom, and here's the slant height of 50. I can figure this out because I actually know what that value is. That is half of one of the sides. Notice midway through the middle of that bottom side is half of what one of the sides is. So it's going to cut it in half, and that value is the same as half of that 28. That's going to be a 14. Now we have a right triangle. We can use the Pythagorean theorem. We can say h squared plus 14 squared is equal to 50 squared. We can solve that by doing this h squared, our height, equal to, if I take 50 squared and subtract 14 squared, I get 2,304. Take the square root of both sides, and I get h equal to, in this case, 48. So the height of this pyramid is 48. So I can fill that number in right there as my height of 48. Now that I've got that, I can go ahead and calculate what my volume is of this pyramid. It's going to be approximately, when I do this, when I multiply it out, 12,544, and since this is listed in inches, it's going to be in cubic inches. So the idea is the slant height, remember, is on the face of the figure, whether it's a cone going along the edge of the cone or along the face of a pyramid. That's the slant height. Use that information, whether the height or the base is given, to calculate out what the height is and find your volume of your pyramid.